Hello, everyone. This is Dr. Rivera again. In this video, I'm going to go over how we collect data, what different types of data we use in psychology, and how we analyze that data. And I want to begin talking a little bit about the difference between population and sample. So, as you're reading, you're going to go over population and sample. And this is something that people often get confused. The sample is a part of the population, and your population is everyone that you care about, everyone that you would like to study, but you can't because you can't study everyone. And so you get a sample of them, you get a representation of them. For example, let's say I'm interested in something about cats in Kissimmee. I care, let's say, how many of them have rabies. Well, if first of all, I can't study every cat in Kissimmee. That's impossible. And so I have to get a sample of them. In this scenario, my population is cats in Kissimmee, all of them. But my sample is the 20, the 100 that I'm actually going to test. Now, one of the important parts about uh, the sample is that it has to be representative. My sample has to represent the entire population. And so let's say I decide to put some traps around Valencia and I collect 100 cats and I study them. I check to see whether or not they have rabies. Well, there's a problem with that. Is that my sample, the 100 cats I trapped and studied, they don't really represent all the cats in Kissimmee because there's a lot of cats in the Loop area that never make it to the Valencia area, in the Poinciana area, or downtown Kissimmee area, or the BBL Lakeside area, or by Neptune. I missed out on a lot of the actual population because my sample is too small and too specific. If I want my sample to really be representative, well, then I have to expand my sample and how I collect my sample. And now instead, I'm going to set a few traps in different areas, and maybe I'll get 10 in the Valencia area, and maybe 25 from the Poinciana area, and 30 from the Loop area, etc. So that my sample is more representative. Also, your sample should be random or randomized, which means everybody in the population should have an equal chance to end up as being part of your sample. Now, this is easier said than done. A good version of this is, let's say I'm interested in uh, excuse me, the opinions of Americans. And I'm going to get a machine that dials numbers in the United States, phone numbers in the United States at random. And so technically, everybody in the United States has an equal chance of ending up in my poll because that machine is completely random. Now, let's say I don't have that. Let's say whatever I'm going to do, whatever I'm going to test, I need someone in front of me. And so I'm going to go to a mall or a park. Well, now that's not quite as random because I'm only collecting the people who happen to be at that park or who happen to be at that mall. And so the level of randomization is not quite as high. But usually we try to be as random as possible in our sampling, knowing that that's very hard to do. Okay. Um, Now, what counts as data? Well, that depends on what you care about. What is the study that you are interested in doing? Some data is what we call qualitative data. This is data that is words, it's concepts, it's ideas. And there's no way to break down those words or those concepts or those ideas into numbers. There's no way to do that. For example, let's say I ask you to write in a journal every day about how happy you are. Well, you know what? At the end of the month, you're going to have 20, 30, 50 pages of just data, of just words that you have written down. How am I going to break that down into numbers? There really isn't a way. And so instead, what I'm going to do is I'm going to find similar themes, similar concepts. Maybe I'll figure out, what do women say versus what men say? What repeats often in them? What do older people say versus younger people? And what I'm looking for is just common themes, uh, but there's no numerical data that I can look at, that I can add up or average out. And so this is what we call qualitative data. Um, Now, some data is very easy to quantify. If I ask you, what is um, your favorite streaming service, Netflix or YouTube or Hulu or I don't know, the DC app, Disney app, and 25% of you say Netflix. Well, that's very easy to quantify because I can count 25% of the respondents said Netflix. That's very easy to turn into numbers. And so that is what we call quantitative data. A lot of times people think that um, uh, qualitative studies are easier than quantitative studies because in quantitative studies, you got to do statistics. And so people often just assume, like, oh, I don't want to do statistics. So I would just rather do a qualitative study. But in fact, those qualitative studies are incredibly complicated because you first of all have to become an expert in a philosophical way of analyzing this data. And then you have to read, papers and papers and papers, maybe tens, hundreds of papers, of interviews, of journals, so that you can then figure out which concepts matter, which concepts repeat, which ideas seem to coincide with which. And um, that can be incredibly taxing on people. And usually the qualitative studies are really long, like they're the way they're written, because you have to explain every detail, and they can be quite overwhelming. Quantitative data is easier to quantify because you just use statistics. Yeah, you got to become a little bit of an expert in statistics, but once you understand the statistics, then you just plug in the numbers and the data comes out on the other side. Um, Now, usually the way most researchers and most research works is that when there's very little data on a topic, we use qualitative studies to figure out which variables matter, which variables show up all the time, which variables can we look at. And so those qualitative studies are incredibly important, especially early on. And then after we know which variables matter, then we tend to go into the quantitative mode and see how often they happen. What if we change this? Will it change how often that occurs? Will we change the statistics? Um, but both of these types of data absolutely matter. However, they're going to completely change what your actual study looks like. And of course, when you write it up, what that write up looks like. Now, I want to talk a little bit about different ways of collecting data. And I'm going to go over a little bit more than a handful. The first one I want to talk about is naturalistic observations. Now, an observation can be done in a lab, but there's a problem with doing an observation in the lab, which is When people know you're looking at them, when animals know you're looking at them, they don't behave in the same way. It's not like a chemical or a force of nature. If I want to study gravity in my laboratory, well, gravity is always the same. If I want to pour, one chemical into another in my laboratory, well, that's going to happen the same way in the field as it is in my lab. But humans, animals are not like that. They will change how they behave if they know you're looking at them. You might have heard of animals like the praying mantis. A praying mantis is a type of insect, and female praying mantises will turn around and eat the head of the male praying mantis while the male is trying to have sex with her. And if you look at this in the laboratory, that happens almost 100% of the time. But if you go out into the field, if you do a naturalistic observation and you look at the animals in their natural habitat, well, that doesn't happen quite as often. Yeah, it still happens sometimes, but it certainly doesn't happen at the same level because animals behave differently when they're stressed out, when they're being looked at, etc., when they're in captivity, right? Chimps in captivity don't behave the same way that chimps act in their natural environment. Now, let me just hit some of these points here. The sample in a naturalistic observation is not going to be super big because it you're just going to see the ones that you see, the ones that come in front of you. If you set up a camera in the middle of the woods to see swans do something or other, well, you're only going to see the swans that happen to be in front of your camera. And so your sample is not going to be quite as high. Um, your level of interference, and this is the one that really matters, is none or almost none. You can't ask questions. You can't put something in the way. You can't change the environment because this is what a naturalistic observation is. You're just observing them in the natural environment. And of course, the environment is the natural environment, wherever you find that animal or person naturally. Now, most of these naturalistic observations are going to be qualitative in nature. Why? Because you're just taking lots of notes. The swan did this, the chimp did that, the person did this. And then you're just taking notes after notes after notes. And afterwards, you're going to try and see what repeats, what is important, what happens in which times of the day, etc. Most of the time, that's going to be qualitative in nature. Can you do a naturalistic observation that's quantitative, where you count how many times the swan does X? Yeah, you can count one, it did it two, it did it three times. But most of the time, naturalistic observations, you're just taking lots and lots of notes, and you end up with a qualitative analysis. Um, if you ever heard of Jane Goodall, Jane Goodall just walked herself into the jungle, set up a little camp, and then she would look at the chimps. And she did this for years and years. She would leave and come back, during certain seasons, and then leave again and come back to the point where her data stopped being naturalistic because the chimps got so used to her, they would come and interact with her. But we did learn a lot of information while she was doing real naturalistic observation because she was observing these animals in their natural environment. And all of a sudden, we realized that those chimps are a lot more like us than anyone had ever thought before. Robert Sapolsky does something similar, but instead of being with chimps, he looks at baboons. And again, we learn a whole lot about baboons from his research. And he specifically does research on neurotransmitters, the chemicals in their brains. And so he will sometimes have to dart them and collect the blood from them so that he can check that out. So his is not quite as excuse me, is not quite as observational because he has to actually collect them, but he does it in their natural environment and he tries to interfere as little as possible. Um, Now, let's say that you're interested in frat guys. Well, you know what? I can't go to the jungle. I'm gonna wait a long, long time in the jungle before I see some frat guy show up um, and study him there. No, I have to go to their natural environment, that frat party, that tailgate where I'm going to find a lot of frat guys, and then I can observe them in their natural environment. And when you do that, you see animals react in ways that they will never react in the laboratory. You're not going to find a mom monkey crying over her dead uh, baby in a laboratory because that's just animals don't act like that uh, in captivity. They don't act like that in the lab, but they do act like that in their natural environment where they're free to be who they are, and no one is interfering. Now, on the other hand, case studies are almost the exact opposite of that. First of all, in a case study, you have a subject of one person. Sometimes you might have two people. Sometimes you might have one group of people. Let's say I'm interested in corporations and I'm going to study one corporation. Well, technically, there's a lot of people in one corporation. But in a true case study, I'm studying one person. Why? Why would I only study one person? Well, usually it's because I only have access to one person. If I'm studying something that's rare, a rare disease, a rare disorder, well, I can't find 1,000 people with this one disorder because it's rare. And the way I got access to this one person is probably that they showed up at my clinic, at my hospital, at my office looking for help. They want you to treat them, right? You, in this case, being the researcher or the doctor. And so you can't tell this person, hey, that's I'm really interested in your disorder, and so I'm just going to observe you from afar and just let you get sick or let you stay, worse, get worse. That's not okay. That would be completely unethical. You instead have to treat them. If the treatment worked, figure out why it worked. If it didn't work, figure out why it didn't work. Try something different. Give this person, I don't know, different ideas, different things to try, and then ask them why they have this. If it is a disease, where did you go? Where did you get this disease? If it's a disorder, tell me about your life. Why did you end up with this disorder? And so, in fact, I have to interfere a lot. The researcher has to interfere a lot, ask a lot of questions, provide treatment, figure things out, etc. Um, and the environment is different as well. In a case study, the environment is wherever the doctor happens to be. Because in this case, the subject came to the doctor, the subject came to the researcher. And um, the data that you collect, it can be all over the place. A lot of it could be qualitative, notes you've taken, things you've tried, all the things the subject told you. I traveled to this place. This happened to me when I was young. There's going to be a lot of notes, a lot of qualitative data to analyze. But some of it could be quantitative and statistical, right? If you do blood work and you find out that this person has some neurotransmitter more, they seem to have more of it than other people. Well, that's probably going to be a statistical analysis. Um, uh, and so you might have statistical and quantitative data, but you're probably also going to have a lot of qualitative data. Now, as I mentioned, in case studies, you're going to interfere a great deal. This person came to you because they needed your help. And so you obviously have to treat them. We'll talk a little bit about Little Albert. Little Albert is a case study. They only studied one person, Little Albert. There in that picture, you see Watson, just a little piece of his head, and Rayner, his assistant, um, or I should say student. And they were studying Little Albert, but they got Little Albert from a hospital, even though what they were doing to Little Albert had nothing to do with his treatment or his disease. They still did get him from a hospital, and we'll talk a little bit about how unethical this study actually is. Um, if you read a little bit about Anna O came to Broward for help. She was sick. She had a disorder. Today we know that she probably had a neurological disorder, but at the time, Brower and Freud didn't really know that. And so they treated her as if though she just had a psychosomatic disorder, when in fact she was dealing with something that was a little bit uh, beyond their ability to help her, and she in fact got a little bit worse. But we'll talk a little bit about Anna O more in depth when we talk about psychoanalysis. Now, you might end up doing a survey or an interview. These are also different ways of collecting data. In a survey, you can have an enormous sample. You can have a sample of 1,000, of 2,000 people. Sometimes you'll see polls, especially political polls, with a sample size of 1,000 people, but they don't always have to be that big. Usually, you're going to determine how big your sample is uh, for, excuse me, for a survey, depending on how many variables you're looking at. If you're only looking at one or two variables, maybe you only need a sample of 100 people. But if you're looking at 5, 10 variables, then maybe you need a sample of 1,000 people. Usually, you rarely need a sample that's larger than 1,000, but some polls and some surveys will get samples that are larger than that. Obviously, there's going to have to be some interference here. Unlike that naturalistic observation, in a survey, you have to ask people the questions. How you ask them might be a little bit different. I can maybe do an online poll and I don't have to be there. And so the person might respond more truthfully because they don't have to look at my face as they tell me something embarrassing, for example. The environment doesn't really matter, but there is some data that suggests that when the interviewer is directly looking at the subject, sometimes the subject won't tell them the truth. And so, if the subject can answer the questions in private or without the uh, researcher having to look at them, then uh, they might get more truthful answers. But then there's another problem, which is if you have a lot of questions, sometimes people will only answer the first half because they get bored. But if you have someone staring at them and asking the questions face to face, they're going to be more likely to just keep on going because they don't want to be rude and just say, "Oh no, I'm going to leave now." So there's kind of a give and take. In a survey, you're almost always going to have a statistical analysis because if I ask you a lot of close-ended questions, well then I can turn that into numbers very easily. Um, Let me show you an example of those. So there on the left, you should see the close-ended questions. For example, which of these is your favorite soft drink? Coke, Pepsi, Sprite, or Fanta? This is a close-ended question because you can only choose these four answers. If your favorite uh, soft drink happens to be Dr. Pepper, well, Dr. Pepper isn't one of the answers. And you have to choose from one of the answers that is given here. Do you prefer to take the bus, a taxi, or an Uber for public transportation? Well, maybe you prefer to take a different thing than a bus or a taxi or an Uber. You prefer to take Lyft. Well, that's not one of the options. And so this is a closed ended question. You have to choose one of these answers. True or false questions are closed ended. True or false, I went to the movie theater a minimum of 3 times this month. Well, maybe you went to the movie theater 3 times last month or the month before that, but not this month. Well, you can only answer uh, yes or no based on this month. And so you would write false here, even though the last 2 months you totally went more than 3 times. A check all that apply, it would also be a close-ended question. Even though you could check multiple answers here, I went to Chili's, I went to Bennigan's, I went to Olive Gardens. You can choose many, but you're still limited by the options here. Now, close-ended questions can be turned into statistics really easy because I can say 30% said true, and the rest said false. Um, people that go to Chili's will also go to Bennigan. Maybe 20% of people who go to Chili's also go to Bennigan. And I can turn that into statistics quite easily. Open-ended questions, I can't really do that for. Interviews are open-ended questions. And so I'm going to have a lot less subjects because if I'm going to have people answer, let's say something for an hour, I'm going to ask you a question, I'm going to give you a whole hour to answer. Well, I have to go over that and I have to go over it over and over and over again. I probably have to type it up and then go over to see what things you said and then compare that to what other people said and come back to it. And so if I have 100 people in my sample for an interview, that's going to be thousands of pages that I have to read. And that's no one's going to do that. That would be a really in-depth study to do something like that. Usually interviews have samples of 20, 50 is a really big sample size for an interview because again we have those open-ended questions, and of course my analysis is absolutely going to be qualitative. I'm going to end up looking for words, phrases, themes, and concepts that repeat. Let me go over some examples of open-ended questions. Maybe I can say something like, what are some issues or problems that you face as a student while attending Valencia? How did you go about trying to resolve those issues? And was the Valencia faculty or staff responsive to your issue? You can't just say yes or no here. You can't just say one thing or two things. You're probably going to go over some things. This happened to me and it was really hard to deal with it. So I tried this and I tried that and this worked and that didn't work. And I talked to this faculty and they were really helpful, but then I talked to this other faculty and they completely weren't helpful at all. And I think Valencia should do this and I think Valencia should do that, blah, blah, blah. And so you're probably going to talk about a lot of different things. And if I'm recording you, it'd probably be half an hour there of you just giving a response. At minimum, even if you don't want to talk a whole lot, you're still probably going to end up talking for at least 5 or 10 minutes as you explain your problem and how you went along with it. And so when you have a lot of those, that's going to take a long time. Maybe I might ask, describe the methods you have used to lose weight and explain which ones have you feel have worked for you and why, and which ones have not worked for you and why did you think that they didn't work for you. Again, You're going to talk for a little while. I tried this diet. I tried these exercises. These diet worked, but this other one didn't because this or that. And this exercise worked, but this other one didn't because of this or that. And so, again, I'm going to end up with a lot of data, and probably that's going to end up being a lot of paragraphs, a lot of words. Um, Sometimes I might just give you a journal and just let you journal for a month. And at the end, I'm going to end up with everything you journaled at the end of the month that I have to read through. These are all examples of open ended questions. And these are going to end up being qualitative in nature. Now, another type of way to collect data is a standardized test. In a standardized test, I need two really important things. First of all, everyone takes the test in the exact same way. If you've taken a SAT or an ACT or your FSA or your FCAT, something like that, then you've probably uh, heard the phrase, please read the directions to yourself as I read them aloud, blah, 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 blah. And even though you took your test last semester and I took it years ago, we still heard the same instructions because we all have to take it the same way. That's a part of a standardized test. This is why a lot of times they spend a lot of time trying to figure out that your worksheet doesn't have any upside down pages, and that everybody has a number two pencil and that everybody has a similar dictionary, because the point is that everybody is taking it in the same way. The other thing that's important in a standardized test is that whatever score you get, quote unquote score, that doesn't really tell me anything. Let's say in that SAT, you got 50 of the questions right and 30 of the questions wrong. All right, well, what does that tell me? You didn't know what was going to be on the SAT. You might have studied or, randomly, but you didn't really prepare, because it's hard to prepare for those kinds of tests. You don't know what's going to be on there. And so that doesn't really tell me anything. What tells me something is when I compare you to everyone else who's taken the test. And so I'm going to compare your score to what we call the norm, everyone else who took the score before you. And now I can tell you, I say the test before you. And now I can tell you that you were in the 20th percentile. That means you did better than 80% of everyone else who took the test before you. Or maybe you were in the 50th percentile. You did better than 50% of everyone else. And so now that comparison to the norm tells me something. A stress test is a standardized test. You're gonna go to the doctor. They're gonna make you run in a treadmill for 5 or 10 minutes, depending on which stress test they're doing. But everybody is gonna take it the same way. Everybody has to run the same amount. And then at the end, I'm going to check your vitals. What's your pulse? What's your heart rate? What's your blood pressure? Maybe how much did you sweat? Again, it's going to depend on which kind of stress test you're taking. Well, let's say your heartbeat is fast. Yeah, well, of course it's fast. You just ran for 10 minutes. That doesn't tell me anything. But now I'm going to compare you to a norm. Everyone else who's taken that stress test before you. And now I can tell you that maybe for your age, your heart is beating too fast. Or maybe for your age, your blood pressure is too high. Because now I'm comparing you to that norm. Babies' growth are standardized tests. The babies are all measured in the exact same way, from the crown to the heel, and then they're going to get measured, compared to a norm, to see if the baby is growing fast, too slow, right at the same rate as they're supposed to be for their age, right? These are all statistical analyses that I'm making based on the comparison to the norm. Now, I want to talk a little bit about analyzing data. With all of the studies that I've talked about up until now, I could just always just report that, right? I could report my naturalistic observations. I could report my case study. I could report my poll, my survey, or my interview, et cetera, et cetera. And that's it. I could just leave it at that. But I could take it to the next level and start analyzing it with a little bit further. And one of the things that I might do is that I might do a correlational study. I might take two variables, three variables, and see if there is a relationship between my variables. That is what a correlational study tries to figure out. Is there a relationship between my variables? If I see one variable change, do I see the other variable change as well? Now, hopefully here we're going to have a decent sample. Uh, my sample should be large enough for my variables. So if I have two variables, I might need a sample size of 20 or of 30. And if I have more variables, I might need a sample size of 100 or 50 or 200. That's going to depend on which variables I'm using. Obviously, you have to interfere here because you have to conduct a survey, or you have to do an observation, or you have to do a standardized test. There has to be a way that you're collecting the data, and usually you have to interfere there. Um, in a correlational study, you often don't need a control group, although you might have one for those quasi experimental ones. But I'll talk a little bit more about that in a moment. The environment may or may not matter. Um, in a correlational study, I'm usually just collecting data and then comparing it. So the environment doesn't always need it. But this is absolutely statistics. It's absolutely a quantitative um, data that I'm looking at. These are going to be number data. Now, my correlational studies, I might end up with a positive correlation, a negative correlation, or no correlation at all. A positive correlation means that as one variable increases, I see the other variable increase as well. So in this one, I'm looking at amount of attraction, uh, so how much you like someone, how much you're attracted to them, versus how similar you are to them. Similar hobbies or similar socioeconomic background, things like that. And so what I see is that, oops, sorry, the more uh, the attraction, the more the similar or the similarities in attitude. And I can see that um, as my similarities increase, okay, from one dot to the next, well, the amount of attraction also seems to be increasing. And the opposite too. The more the attraction decreases, the similarities are also decreasing, right? If I go from this dot to this dot, well, I see that there is a decrease in similarities, and there's also a decrease in attraction. They're going down together. Um, so for positive correlations, my variables move in the same direction, both up or both down. But in a negative correlation, the opposite is happening. As one variable goes up, I see the other variable go down. So if I go from this dot to this dot, okay, as degree of depression decreases, what I see is that the relationship of satisfaction is actually increasing, it's going up. So as this goes up, this we're going to the right now in depression. That is, we're going down. And so the opposite is also true. As depression goes up, well, then relationship satisfaction goes down. So as relationship satisfaction is going down here, well, We're going now to the right in depression. That is, we're going higher in depression. And so what you tend to see is that as one variable goes up, the other one goes down. Um, Now, in the last one you're seeing over here, um, you see that these numbers are just kind of scattered randomly. And so if you try to run this through a statistical analysis, what you would find is no correlation or a correlation of zero, meaning that there is no relationship between these variables. Um, Usually, you're going to get a correlation of anywhere from 0 to 1 or 0 to -1. If it's a negative number, then what you have there is a negative correlation. And when it's a positive number, then you have a positive correlation. And so if I come back here, uh, the first graph is showing a positive correlation. Probably if you're trying to figure out slope, like if you were in your math class, uh, in your algebra class, then this would be a positive slope, a positive number over a positive number, or a negative number over a negative number. And so you would end up with a positive correlation or a positive slope. In the second or middle um, graph here, you would end up with a negative correlation. And again, if you were looking for slope, it would be a negative number over a positive number or a positive number over a negative number, meaning that your R or your correlation or your slope would be a -1. And as I mentioned, a correlation of 0, well, that's just going to be no correlation at all. Now, another thing you have to think about when you think about correlation is the strength of it. A correlation can be strong or weak. Um, what you're seeing in the graphs there, first of all, is a positive correlation. In the first one, you have a strong correlation. And you know that it's a strong correlation because you can almost see the line without having to run the data, without having to run the statistics. The graph by itself shows a really tight line. The example here is your grade in math versus how many study sessions you have. And you can see that the more study sessions you have, the higher your grade in math tends to be. In the second graph, you can still kind of see that there is a correlation there just by looking at it, but that is not quite as tight. The line is not quite as obvious. And so you can see that the correlation would be a little bit weaker here. Now, in that last graph, um, the the dots are almost entirely random. There's a good chance that you're going to end up with a correlation of 0 here. You'd still have to run it through your statistical analysis. Maybe you might end up with a really weak correlation uh, somewhere in there, but probably you're going to end up with a correlation of 0, meaning no correlation at all. The same thing over here, but now I'm showing you some negative correlations. Um, in the uh, first graph, in the left, you are going to see a weak correlation, or maybe even a moderate correlation, um, uh, but it's going in the opposite direction. You can see that this is a negative correlation because as one variable is going up, your grade in math class, um, the number of parties you go to seems to be going down. Um, Over here in the graph to the right, this is still negative, but now you see that it's a lot tighter. And so you can assume that this is going to be a very strong relationship or a very strong correlation, but it would still be a negative 0.76 perhaps. As opposed to a positive 0.76. which is the one you would see here at the top on the left. All right. Um, Now, some examples here. Uh, the number of ice cream sales in any given city are correlated to the crime rate in that city. That's a real correlation that exists in life. The more ice cream gets sold, the higher the crime rate. This is a positive correlation because they're both going in the same direction. The more crime rate, the more ice cream sales. And when ice cream sales go down, the crime rate goes down as well. Now, um, this is just a correlation. There is a relationship. It's important to point out that ice cream is not causing crime. These it just happens to be a correlation that exists. It could be some other third variable, maybe heat, right? If it's hot, people are more crabby, they are more irritable, and maybe they're more likely to start a fight. And of course, if it's hot, then it's more likely that you're going to have some ice cream. Or maybe it's something about the season. Uh, in the summertime, there's more kids out getting into trouble, and so the crime rate goes up. And when the kids are out from school, then parents buy more ice cream or something like that. But in any case, what we're seeing here is a positive correlation. As one variable goes up, the other one goes up too. And as it goes down, the other one goes down as well. Here's a very strong correlation in psychology. Um, your ability to have self control at 5 years old is directly related to the SAT score you get in high school. How do we measure this? We tell a kid that they've won a marshmallow, but then we tell them to wait. If you wait for me, I'm going to leave the office. And if you wait for me and don't eat the marshmallow, when I get back, I'll give you a second one. Well, before around 4 years old, no one can do this. All the little kids eat the marshmallow. But right around 5 years old, some kids can wait and some kids cannot. The kids that can wait, when we find them again in high school, they tend to get higher um, SAT scores than the kids who could not wait. This is a correlation of about a zero point 0.8, which in psychology is ridiculously high. Um, Here's a negative correlation. The higher your degree, the higher or the longer you're in school, um, the lower the chances that you end up in jail, right? And this goes the opposite, right? The less schooling you have, then the more likely you are end up in jail. Again, this isn't necessarily causal. It's not that one thing is causing the other, um, but probably if you have a high degree, you probably make a little bit more money. You're less likely to have to need to steal something. Maybe you're shyer or you're less extroverted, um, and so you're less likely to sort of get yourself into trouble by starting a fight or something like that. This isn't necessarily a causal relationship. One thing doesn't cause the other, but the relationship is absolutely there. We've measured it over and over again, and this is a negative correlation. As one variable goes up, your schooling, the other variable goes down, the chances that you end up in jail, and vice versa. Now, it's important to point out, and I've said this over and over again, that just because two things correlate does not mean that the relationship is causal. The relationship is there, but it's not necessarily a causal relationship. And you can look at just about any correlation and see that if you stare at the data. For example, here we have number of parties that a student went to versus their test grade. And you can see that there's a clear correlation here. That purple line shows that uh, the more parties you go to, the lower the test score on average, and vice versa. The fewer parties the student goes to, the higher the test grade. This would be a negative correlation. But you can look at the data and see that the one thing doesn't really cause the other. If you look at this horizontal line, well, you can see that these two students went to the same number of parties, and yet they ended up with very different scores on the test. That's because, there's a bunch of third variables that could be affecting this. By the way, we call, even if there's many third variables, we call them third variables. So maybe, this student went to a test yesterday, and so they're still hungover from all the drinking they did. Where this student, yeah, they went to the same number of parties, but the last party they went to was last week. And so they had a chance to rest and study for the test, etc. Um, Here we have a student that went to more parties than this student, right? And yet they ended up with a higher grade than this student. Because, of course, the party didn't make you get a high grade or not, but it affected it. And so when you are studying 100 kids, 50 kids, well, then you're going to see a pattern emerge. And in this case, the pattern is a negative correlation. This is a really important thing to remember. Why? Because people make mistakes here all the time. They'll get a correlational study and they'll assume that the correlation is causal, when in fact it isn't always causal. Here are some random correlations that have nothing to do with each other. The number of people who drown by falling into a pool versus films Nicolas Cage appeared in. And so, well, you see that that correlation is really neat, it's almost perfect. But clearly, no one is drowning because of how many films Nicolas Cage appeared in. Nicolas Cage is a fine enough actor, but people aren't, I don't know, killing themselves because he did one too many or one too few uh, films. In the next one you're seeing here, the people who drowned after falling out of a fishing boat versus the marriage rate in Kentucky. Um, and you can see that the correlation is pretty neat. They're pretty close to one another. Um, but again, these things really have nothing to do with one another. They just happen to correlate. Here's another one that's a little bit more related, but not necessarily. um, not necessarily causal. The total revenue generated by arcades, so how much money arcades are making compared to computer science doctorates awarded in the U.S. And you can see, I mean, in some cases, this correlation is almost perfect. But how much money the arcade makes doesn't really have anything to do with who's going to school to get a doctorate in computer sciences. They might be closely related because maybe, kids who like video games get interested in computers. Sure, there's a connection there, but the one thing doesn't cause the other. And so this is just a correlation. As I mentioned, this is a problem that happens all throughout history. People make this mistake all the time. Frederick Wertham, one of the famous examples here, um, made a correlation between, or found a correlation between juvenile delinquents and comic books. So he was really interested in the 1950s, studying why kids became juvenile delinquents. And so one of the things he used to ask kids was, "What do you like to read?" And it was the 1950s. And so kids all read comic books. Comic books were a little bit different then than they are now. In the United States, back then they had like detective comic books and horror comic books, and some of them were really gory, some of them were quite sexual. And so um, Wortham saw that, and he made the correlation. He assumed that the correlation was causal. He thought the comic books are turning these kids into juvenile delinquents. And so he wrote a book about it. It got all the way to Congress, and Congress almost made comic books illegal in the United States. And the comic book industry decided to regulate the comic books so that they wouldn't get made illegal. And so the way they regulated it was really tough. And so the only comic books that got made, the only stories that got written, were stories where there were a clear good guy, and good always triumphed over evil. And so what does that sound like? Well, superhero comic books. And that's why in this country, when you say comic books, almost everyone thinks about superhero comic books. um, and yet in other countries, comic books have nothing to do with superheroes. There's sports comic books and romance comic books. um, but in the United States, we almost always think of superheroes when we think of comic books, because someone made a mistake about a correlation once. And all throughout our history, there are issues with this. The self esteem movement was a problem with a correlation. There was a correlation that said kids who do well in school tend to have high self esteem. And they could have read that correlation backwards. They could have said, yeah, of course, when you do well in school, you tend to like yourself a little bit more because you're doing well in school. But they didn't read it like that. They read it, well, if we can get kids to have high self esteem, then they'll just automatically do well in math, which of course doesn't really make any sense. But a whole movement came out of that. And so now your teacher isn't allowed to write your name on the board because it hurts your feelings. And now you can't learn fractions for some reason. Well, that doesn't make any sense, really. Um, Self-esteem is important, but that doesn't, there's a lot of people who hate themselves who can succeed, and there's a lot of people who love themselves who don't succeed at all. In fact, one of the things that criminals tend to have in common is that they have really high self-esteem. And so we know that that's just a correlation. It's not causal. The one thing doesn't cause the other. And this is a mistake that people make all the time. Now, if you're interested in causal relationships, did the variable cause the other variable to change? Then there's only one way to do that, and that is through an experiment. Now, I know we use the word experiment to mean almost any study, but if you're doing science, an experiment is a very specific kind of study. It's a study where you manipulate the variables to determine if one variable causes the other variable to change. Now, in a true experiment, the sample size might, you might need a big sample size depending on how many variables you have, just like a correlation. But in an experiment, it's harder to get uh, a big sample, because you need people to come in and you need to manipulate them somehow, and you need to measure things, and you need to maybe ask them to come back, or blah blah blah. And so it's harder to get that big sample size. And so you might end up with a sample size of 20 or 50. If you have 100 people in your experiment, that tends to be really big. Now, if you're a big corporation, let's say what you care about is some pill, and you work for Bayer and they're a rich company, well, then you might be able to get a big sample size of 1,000 people, because your company is really interested and they have a lot of money to waste. But if you're just a lowly researcher in a college, there's a good chance you don't have that kind of money. And so your sample size is going to be limited by your resources. Now, in an experiment, you absolutely have to interfere, because you have to conduct a survey or do the test, make an observation, change something, etc. And so You have to somehow manipulate the variable for one set of people and change it or not manipulate it for the other. There's a lot of interference as far as the researcher is concerned. The environment, the thing that matters in the environment is that they're similar. If my control group is, you know, in a lab, well, then my experimental group should also be in a lab as well. If my control group is at home, then my experimental group should be at home as well, because I only want to change one thing for those groups, and that's going to be my independent variable. That's the only thing that should be different between my control and my experimental group. And of course, my analysis is going to be a statistical one. I'm going to see, is there a difference between my control group and my experimental group? Now, I've been saying independent variable, dependent variable, control group, uh, experimental group. People sometimes have a real hard time with these words, with these vocabulary. And so I just want to sort of show it to you visually. My independent variable is the thing that the researcher changes, right? Anything that's a variable changes, right? As opposed to a constant, which always stays the same. My variables change, but the independent variable, the researcher makes that change. And so that usually is going to be the thing that gets manipulated or doesn't get manipulated. Let's go back to that corporation, and you're interested in whether or not the pill takes away pain. Well, I'm going to give some people a pill, a real drug, and I'm going to give some people a sugar pill. I probably won't be a real candy, but it'll be some sort of sugar pill that looks like a real pill. And my experimental group is going to get the real pill, and my control group is going to get the sugar pill, the non manipulated variable. Now, my dependent variable, that's the thing that I'm measuring. Okay. And so what am I measuring here? Pain. And so high pain, low pain, that's going to depend on whether or not you got the real pill or you got the sugar pill. But in any case, it is my dependent variable because that's the thing I'm measuring at the end. So again, my independent variable, that's the thing the researcher changes, and my dependent variable, that's the thing that I'm measuring at the end. Let me give you another example. Oh, I'm sorry. Again, the dependent variable is dependent on the manipulation, on the independent variable. Now, maybe I'm interested in what kind of shoes affect ankle pain or ankle injury. Well, again, the thing that the researcher changes, that's the independent variable. I'm going to give one runner some Nikes and I'm going to give the other runner Adidas. Well, that's the thing that I changed. And so therefore, that's the independent variable. Which one is control and which one is um, uh, experimental? Well, here it just depends on which one I care about. In the in the pain one, in the pill one, obviously the sugar pill is the control group because that's the non-manipulation. But here, I'm giving somebody a shoe regardless. I probably, let's say I work for Nike. Well, then I probably care about Nikes. And so that's going to be my experimental group in this scenario. And if I don't care about Adidas, then that's just a shoe that I don't care about. And so that's just going to be my control. But my dependent variable is the pain here or the ankle injury. How much ankle injury do you get if you wear Nikes versus if you get Adidas? This is going to depend on the shoe that you got, on the manipulation. And so this is the dependent variable. It's also the thing that I'm measuring at the end. How much ankle injuries or how much ankle pain um, do you have at the end? And so this is my dependent variable. Now, you might be asking yourself, why do I need to have a control group and an experimental group? Well, the problem there is that if you don't have any control, everybody has pain here. All of these people have pain, and I'm going to give them all my red pill. Well, you know what's going to happen? Some of them are going to tell me that it worked, and some of them are going to tell me that it didn't work. That's always going to happen. If I give them all my blue pill, the same thing. Some of them are going to tell me that it worked, and some of them are going to tell me that it was a waste of time and that it didn't work. So, which one actually worked? Was it my blue pill or my red pill? Well, like this, there's no way to tell. So, instead, what I'm going to do is I'm going to split up my sample, and I'm going to split them up into a control and a excuse me, and an experimental group. And I would like to do this randomly, put their names into a hat and randomly assign them into an experimental group or the control group. Why? If I split them up almost any other way, right? Maybe they're seated somewhere and I go, this half is just going to be my control group, and this half is going to be my experimental group. Well, maybe they sat together because they know each other, or maybe they sat closer to the door because they have more pain and they didn't want to walk or something like that. And so all of a sudden, I'm adding new variables to it. But if I split them up randomly, then there's an equal chance that they're going to end up in either the experimental group or the control group. And so that makes my assignment a little bit more equal. Okay. Now, what's going to happen is still the same thing. I'm going to give my experimental group the blue pill, and I'm going to give my control group the red pill here. And when I measure it out, some people are going to say it worked, and some people are going to say that it didn't work. Well, that's going to be, if I just, you know, listen to them, hey, some of them said it worked and some of them said it didn't work. Oh, which one is which? Well, I'm gonna measure it, and I'm going to see in my experimental group how many people said that it worked, how many people said that it didn't. In my control group, how many people said that it worked, how many people said that it didn't. And when I measure them out, I'm going to find out that 75% of the experimental group said that it worked, and only 25% said that it didn't. And in my control group, 20% said that it worked, and 80% said that it didn't work. And so what I see here is that in my experimental group, it worked for more people. And in my control group, it didn't work for more people. And so what I can see is that my blue pill worked and my red pill was just was a failure. It didn't work. And this guy, the reason it worked for him was probably just a placebo effect. He just took a pill, and the fact that he took the pill made him feel better. We all know that sometimes happens. Um, if I give you, I don't know, I can give some people some magnet bracelets, and the fact that they have the magnet bracelets takes away their headaches. And who am I to argue with them? The headache went away. But we know that it's just a placebo, because if I try to do an experimental in a control group here, what I'm going to find is that magnet bracelet, it doesn't work for most people. Even if it does work for some people, for the people that it works for, it's just a placebo effect. The fact that they have it makes them feel better, and so their headache goes away. Um, Let me come back here though. I want to make one more point. Now, I went over here the true experiment, but over here I have something called a quasi experiment, because sometimes you almost have a true experiment, but not quite. Maybe you have a control group and an experimental group, but you can't randomly assign them. Like, let's say that I'm comparing men versus women. Well, I can't randomly assign George to be a woman, and I can't randomly assign Susie to be a man. And so that is going to affect my experiment. And so this is a quasi experiment, almost an experiment. Um, Sometimes it's not that. Sometimes it's that the way I manipulate the data is odd. Maybe I am just testing everybody and then retesting them later, and so there's going to be things that interfere there, and so that might end up being a quasi experiment. Um, so it's quasi means almost an experiment, and so it meets uh, most of the things that you need to be a true experiment. But there's probably one thing that it doesn't meet, and so we call it a quasi experiment. A lot of correlational studies are actually quasi experiments, not all of them, but sometimes you end up having a control group and an experimental group, but not enough of the requirements for a true experiment. And so you just end up with a correlational study that's a quasi experiment. All right, let me just jump down here and let me make the point that um, experiments have a few advantages. The main one is that we can figure out a cause and effect because we can see that one variable affects the other or one variable does not affect the other. And so we can say that the relationship in an experiment is a causal relationship. That is, one thing caused the other. And you can't do that in a you can't do that with a correlation, and you absolutely can't do that if you are only doing just a naturalistic observation, for example, or just a um, just a survey. But when you do an experiment, then you can figure out that the one thing caused the other. And so they also allow us to address the goals of explanation and change in psychology. There are a few drawbacks. One of the biggest drawbacks is that they do not address the goals of description. And so in an experiment, you're not really describing the phenomenon. You're just sort of explaining that the one variable caused the other variable to change. Sometimes when you observe something, it changes the way people behave. This is the issue with almost anything that isn't a naturalistic observation. As soon as you start interfering, it affects how people change. And this is the problem. Um, and there are variables that you can't study ethically in an experimental method. Let me give you an example. Let's say I have a drug that might cure people if they have cancer. And I'm going to give people, uh, my experimental group is going to get my cure, and the other group is going to get a sugar pill. Well, that's kind of unethical because everybody who got that sugar pill thinks it's a real drug, and they probably stopped taking other drugs. Maybe they stopped going to chemo because they think this drug is going to save them. And so now what? You're just waiting for them to die, knowing that the drug they're taking is just a sugar pill? That's not okay. That's unethical. Now, there are sometimes ways around this. Some researchers will do things like in January, group one begins taking the drug, and all the other groups are just taking a sugar pill, or maybe they're still on just chemo. And in February, group two starts taking the pill, and in March, group 3 starts taking the pill, et cetera, et cetera. So there are ways around it so that you can be as ethical as possible and still maintain some form of an experimental design, or at least a quasi experimental design. Um, but it sometimes it's just completely unethical to do an experiment in that way. Another example is, is it okay, or does hitting, using corporal punishment affect your child's, I don't know, aggression levels? Well, I can't randomly assign a parent to hit their child, right? Imagine if someone came up to you and said, "Hey, for my experiment, you have to start hitting your child." Maybe you're not really into that. You think that that's wrong. Well, that it would be wrong for me to ask you to do that. And the opposite. Maybe you're a parent who uses corporal punishment, and I'm going to say, "Hey, I'm going to randomly assign you to be a non-spanking parent, so you have to stop spanking your kid." And maybe you don't want to. You think that that's something that's important. And so that would be unethical for me to ask you to change the way you parent your child, especially if it involves hitting someone. And so that would be kind of unethical for me to ask that. And so there are certain limits to experiments. All right, I am going to pause here in the third variable, excuse me, the third video for chapter 1. I'm going to talk a little bit about ethics, a little bit about the history of psychology, and I'm going to talk a little bit about modern psychology and some of the different types of jobs that you might be interested in.